Our work on page 27, please. 27. We've already done the first little bit. Let us carry on. So we have discussed prisms, and we have discussed how a prism starts from one shape, and that shape repeats over and over again. So if it's a rectangle prism, it's a rectangle that repeats. If it's a circular prism or a cylinder, that circle repeats. If it's a triangular prism or a wedge, the triangle repeats. Nick, you had your hand up. What? Okay. Next, we are going to talk about pyramids. How does a pyramid differ from a prism? When I say the word pyramid, what's the first thing 99% of you are going to think of? Egypt, right? That's why I said 99%, TJ. There's always one kid that doesn't say Egypt. Okay, so, indeed, pyramids are prisms' ugly cousins. Do they have 3 dimensions? Yes, but they aren't pretty like these guys. They don't all work. So a pyramid is still 3D, but the L, W, and H are not constant. They do change. Constant. There we go. So how would you describe a pyramid using words similar to how we defined a prism? How does a pyramid start? Starts from a base shape. Need that base be on the bottom, Sam? It does need to be on the bottom? Why don't we use that word, Aiden? There are infinite bottoms. What's the bottom of this box? Where is the bottom of this box? There isn't a bottom of this box. Why? Because right now it's this, yes? Until I turn it this way. Now what is it? This. Until I turn it this way. Now what is it? Until I turn it on that point. Now what is it? Does the bottom even exist? No, because it's a single point. Right? Okay, so we want to be careful with that. But, Sam, we discussed how base could be used properly. The other definition of base. What is a base? No. A foundation. Right? No matter what I choose, if I call this the base, that rectangle repeats back to this rectangle. So the base is a rectangle. You with me? How would that work with a pyramid? Does it start from a base? Yes. Excellent. But then what happens to it? Does it repeat?
No. Yeah, and it gets bigger.
Bigger?
Depends where.
Right. It depends on the direction we go. Right? So we still start from a base shape. That shape still repeats. But what happens to the dimensions of that shape? But the shape's dimensions, well, they shrink or they grow, right? So let's say they change. Everyone agree? Yeah. So, thinking back to Egypt, the bottom of the pyramid makes a nice square, yeah? Halfway up the pyramid, we still have a square, don't we? But it's smaller. At the top of the pyramid, we got nothing. Everybody with me? So draw the lopsided L, draw a triangle, and then connect the last one. Okay. What other shapes can we have for a pyramid? Can I start from a circle? And what happens then? it becomes a cone or a circular pyramid, right? We start from a circle and they get smaller and smaller and smaller and smaller and smaller, and then they disappear. Can I have a triangular pyramid? Sure, I'd start with a triangle, whoop, and I'd shrink, 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 and it would disappear. Could I start with an octagon?
No.
Sure I could.
That'd be cool.
It would just shrink, 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 shrink to a point.
Actually, yeah.
You can start with the square, you can start with the rectangle, you can start with anything, right? Okay, so I'm not going to draw the triangular pyramid because they're really difficult to draw and they look stupid. So I'm not going to draw one. But they do certainly exist, yes? All right. Next thing we need to talk about. The first thing we are going to talk about in grade 10 that you already talked about in grade 9 is this concept right here. Total exposed area of a solid. This lid is, if I didn't have fat fingers, that lid is now closed. Agreed? What is the exposed area of this solid? The surface area. Where would you describe it? Use another word for me. Use another word to describe the surface area of this. The outside. Excellent. Why? It's the part you can see. It's exposed, right? If I turn it around, you can see all of that, yeah? What happens if I open it? Now what's the surface area? The inside and the outside, except what's missing? The top is gone. Or we'll call it the top because it was the lid. But we've lost that rectangle, haven't we? I had the bottom before. Wait, I know, Aiden. I know. I'm messing with your... But I had the bottom right here. Now you're supposed to say, but Mr. Myers... Now say it.
I can't because it's closed back up.
Son of a... Now say it. You gained the bottom, right? Everybody with me? So even though I took away the lid, we lost one of the faces. We actually gained surface area because now all of this inside is exposed.
You lost the face, but you gained it back to the floor.
Yes. Yes. Everybody understands? Josh.
So opening the box would have more surface area than closing the box?
Yes. The math in this section is super easy, but the concepts are weird, right? I took away some of the box, but I gained surface area. All right, everybody cool? All right, so let's do some work with this. And you're going to need your calculators out, so if you don't have it out, get it out now. My computer is frozen, but maybe soon it will not be.
I went to class without the period reason.
Ta-da! Now, if I hold this up as a cereal box, you are quite all obviously aware that it has 3 dimensions, yes?
Yeah.
But of course, you cannot draw 3 dimensions on 2 dimensions of paper. That's why we go with the diagonal line, yeah? Mm-hmm. Excellent. Now, if I want the exposed surface area of this, that must be that rectangle, right? Everyone agree? Plus that rectangle, right? Everyone agree? Plus that rectangle, right? Everyone agree? So that's the surface area. No, why, Aiden? Absolutely right. So if I knew all that, I would have to multiply it by 2. Does everyone agree? That's grade 9, right? Everyone's cool with that? Okay, now, The next thing I need you guys to do is all 30 of you need to tell me, don't write it down, just think in your head, don't all yell out the answer. What shape is that green thing? Everybody got it? Okay. How do you find the area of that shape? All right. So there's a length times width of the green rectangle, yes? Okay, what about for the yellow rectangle? Length times width. Okay. What about for the blue rectangle? Length times width for the blue rectangle. That's lovely, yes? Everybody write L and W everywhere you need to write it. Make sure you do it in pencil, please. If you need to color it, Nick, you feel free to color it. Because according to you guys, I need 3 L's and I need 3 W's, right? You all told me I need LW for a rectangle. I got 3 rectangles, so I must need 3 L's and 3 W's, right? So, the question that has to be asked now of all of you is, you all knew that a rectangle is length times width, right? You all conceptually understand that this prism is made up of 6 rectangles, yes? And you all understand that a rectangle, you must therefore have 3 lengths and 3 widths. Except, of course, we don't have 3 lengths and 3 widths, do we? Okay, so which would you call the height, Sam? I'll change some colors. I'll put a red line, I'll put a blue line, and I'll put a green line. Which would you call the height? You would call the red one the height? So you want to call that guy our L, right? Which if that guy's going to be an L, what does that make the blue line? So I can do the green question. Okay, that makes the blue line width, yes? Okay, so there's an L and a W. So what then is left over here? That's the height? So Sam would like to change his red length to a height. Okay, so then what does that make the green line? But you've given me width down here because you wanted length times width. So this should be the length. Okay, so you want to move your length down to here. Okay, so now what? So then my green line becomes the width. Are you happy now?
It depends on the way that you're looking at the shape.
Thank you, Sam. That's the point. Does it matter?
No.
No. You guys get locked into formulas. Length times width. That's what a rectangle is. It's length times width. Has to be length times width. But it's not, is it? Right? It's one dimension times the other dimension. Yeah? So all I got to do is recognize that I need all those measurements, and it doesn't matter what they're called. Okay? So how will I find this green area with the letters the way we have them? Length times height, L times H. How will I find the yellow area with the letters how I have them? W and H. And how will I find the blue area with the letters how I have them? L, W. And what must I do with those 3 numbers? Put them in brackets. Then what? Add them. Then what? Multiply them. Right? So, if we were going to write this out, because we should write it out, because showing our work is important, we would have 2 bracket. What is LH? What numbers are LH? Does it matter? No. So what is LH? You want to call it 40 and 24? Okay. Which means WH must be what? 8 and 24. And LW must be what? 40 and 8. Everybody understand? Now, punching that into your calculator is actually very difficult to do all in one shot. I would like for everyone to try. All at once. Your fingers cannot leave your calculator. You can't write anything down. See if you can do it. Because there's a reason I'm doing this. And when you have an answer, put your finger on your nose. None of you will, because you're not fun. Oh. Thanks, guys. That makes me so happy. Thanks, Nolan. Thanks, Jake. Would anyone like to volunteer their answer? Jake.
2,944.
Jake says 2,944 what? Kaboobly Heinz's? Centimeters squared. Why did you remember the squared?
Because it's area.
Area, and area has how many dimensions? 2. Excellent. Does anybody have anything else? Everybody in the room got 2944 when they punched this into their calculator in one shot. This is the best class I've ever had.
Isn't the right answer?
Yeah.
That was straightforward and easy.
I know that. I know that, Jashin. I know how easy geometry is, but I also mark your tests.
But why did you say it was hard?
Because when I mark this in about 5 days, when I give you the test on this, a bunch of you are going to get this wrong. And I don't know why. Because you're going to be able to do it right here. And then when I ask you about it on your test, you're going to say, and I quote, "My calculator said so." So now all of you are screwed because you just punched it into your calculator correctly. So now none of you can hand me that line of crap in a week. Can you? Excellent. Good. Let us move on then, cabbages. That's the right answer. Oh no. So, thank you. I did ask, did anybody get something different? Oh, did you? I'm sorry, Riley. I didn't hear you. So what do you need to do to fix that? The question, is the problem your calculator? Or is it how you're telling your calculator to do its work? The calculator only do what you tell it to, right? So, if you weren't able to get this in one shot, how do you fix that problem? No. Do it piece by piece. Because your calculator can do 40 times 24, super easy, right? That's 960. 8 times 24, super easy. That's 192. 40 times 8, super easy. That's 320. Then you can add that up, super easy. That's 1472. Then you can multiply that by 2. Super easy, 2944.
I'm guessing you forgot the brackets.
Picking up what I'm putting down? Don't assume that because you are mashing calculators on your buttons, mashing buttons on your calculator, that you are doing math. Do you understand? Never once will you get a prize in my class for finishing your test first. It is not a sprint. You are not the Usain Bolt of the mathematics world. Okay? Take your time and do it right. Because let's be honest, Riley, I'm not trying to pick on you. This was easy math, wasn't it? What made you get the wrong answer? Not you, the way you used the tool that you have, the calculator. Everybody good? Sweet. Now, guys, I apologize. Your next page was the page from my honors book. This question, no, I fixed it. The question you guys have written is crazy impossible. Okay, so I want you all to make these changes. Cross out the word rectangular and write square. You can do it for bonus marks. I'm getting to that. Which has a base dimension of 32 feet square. No. 32. That's supposed to say 32 by 32 because it's a square pyramid. Yeah? Okay? And it's got a height of 65 feet. So now, I would like for everybody, again, do this in pencil, please. On the left-hand side of your sheet, try to draw that pyramid for me. There's two ways you could draw it. I'm interested to see what you do without me telling you what to do. Draw that pyramid. There's two ways you could do it. Go. If you can't think of a way to draw it, then just chill. We'll draw it in a minute. Awesome. When you do it, pull on your left ear.
This is a normal pyramid.
I want your left ear long enough that you can, if the wind picks up, you start walking in circles. Yes. Okay. How many people drew it this way? 32 by 32 with a height of 65. That's one way you could draw it, yes?
Yeah.
Did anybody draw it this way? 32 by 32 with 4 triangles.
Whoa.
Because all those 4 triangles would fold up. Nina, knock yourself out.
I'm sorry.
Two ways we could do it, yeah? All right. So now we look at this and we say to ourselves, self, the area of this must be what? It must be that, which is what shape? A square or a rectangle, right? So it happens to be length times width, but since it's a square, length and width are the same thing, aren't they? Right? So let's call it B for base squared. Everybody cool? Okay. And then there are how many of those? 4. How do you do the area of a triangle? So it's a square plus a triangle plus 4 triangles. What is one triangle? Say it again, Joshua, please. Base times height divided by 2, correct? But how many triangles do we have? 4 of them. What happens to that 4 and that 2? They cancel each other out, and I end up with 2 base times height. Does everyone agree? Is everyone cool with that? Okay. Now here's where it gets tricky. Read the question again, and it says the height of the pyramid is 65. Where do you measure height? From the very top to the base. Where? Through the middle or down the side? Through the middle. Isn't exposed area for surface area supposed to be on the outside? So this 65 is going right down the middle. So does that help us? Is that height the height I need for a triangle?
Yes. Right.
Is it or isn't it? No, it isn't. Why, Sam? I need the height that goes up the side of the pyramid, don't I? Right? That's what makes it tricky. Again, is the math complicated? It's just base times height. But is the concept complicated? Yes. So I need this height up here. How do I get that? What shape is this? What kind of triangle? A right triangle. Do I have a mathematical tool that finds the length of sides of a right triangle? A squared plus B squared equals C squared. So this H from our triangle formula is not the H in our pyramid formula, is it? So I need the height in the triangle, but in a pyramid, as Sam said, in a pyramid, it's the slant height that I need. Picking up what I'm putting down? So how do I find that slant height? Slant height always equals a squared, b squared, c squared, right? The square root of the height of the pyramid, the real height, plus what number down here? The whole base or half the base? Why half? Because you go up to the middle, plus the base divided by 2 squared. Again, is any of this math complicated? It's all the stuff you already know. Pythagoras, I know Pythagoras, I learned that in grade 6. Base times height, I know that, I learned it in grade 3. Length times width, I know that, I learned that in grade 2. Putting it all together, that's what's difficult. So how do I find this slant height? Square root, what's the height of my pyramid? 65 squared. Plus, what's half my base? 16 squared. And then I punch that into my calculator, I'm going to get a number. What number am I going to get? It will be a decimal. So we then have the argument, what do we round it to? Square root of 65 squared plus 16 squared. 66.94. What do you think I would be comfortable with you rounding that to? 67 is fine with me. So now I know my S, which is what I need to be the H in my triangle, right? So we have B squared plus 2B, but we don't want to say H. What do we want to say there? S. Do we know S?
67.
So it's B squared. What was B? 32 squared plus 2. What was B? 32. What was S? 67. And now I can punch that into my calculator. Is everybody with me? Where'd you get lost? Are you cool with the fact that it's got a square on the bottom? What part? That's not true. You know how to find the area of a square. Length times width. 32 times 32. Okay. Do you understand that there's 4 triangles? Okay. Do you understand that triangles are base times height divided by 2? Okay. And since there's 4 of them, 4 divided by 2 means 2 base times height. You okay to there? Cool there? Okay. Now height is where we get into problem. Because the triangle has a height, but the pyramid has a different height, doesn't it? Because the pyramid height goes straight up the middle, not up the side. So we took this triangle right here, which was, nobody write this down, this is explanation. It was 65 up the middle, yes? And the bottom was 32 all the way across. But since this only goes to the middle, this is 16. Cool still? So the side of the pyramid must be that hypotenuse, right?
Opposite of the right angle.
Okay. So 65 squared plus 16 squared, and then I square root it, and that gives me up the side, right? And up the side, Riley, is the slant height, but it's the height of the triangle I care about. Cool? I know it's fast, don't get me wrong. I'm aware of that, but it's a short day. That's the only reason. And because I like to point out that you know all the math already. We're just applying it differently. Okay, look at number 3. It's a cone. What shape is on the bottom of a cone? Circle. So we know it's a circle. And isn't a cone just a round pyramid? So we know pyramid needs a slant height, don't we? Right? We had to find the slant height in our pyramid. So do you think I need to find the slant height here? Yeah, I do. I got to multiply something with the slant height. So I got a circle, right? That's going to cover the bottom. And then this outside shape here. That outside shape, what is a pyramid? How did we define it? No. Oh, sorry. What is a cone? How did we define it? It's a circle that repeats and gets smaller, yes? So that circle is still going to be pi and r, isn't it? But is it going to be the radius, or do I need that slant height? I need that slant height. How do I find the area of a circle? Pi r squared. That covers the circle. How do I find the diagonal part? Pi r slant. Everybody cool?
Yeah.
So, look at my question. Do I have a radius?
Yep.
What is it?
15.
15. So, r must equal 15. Do I have a slant or do I have a height? Height. What do I need to do whenever I need to find slant? Why? Because it makes that right angle triangle, right? So how long is this side? 22. How long is this side? 15. What math do I do? I wrote 12 because I'm an idiot. 15. What do I write there? That's the Pythagoras part, right? Because slant always equals what? Square root of the height, which is what? 22 squared, plus the square root of the bottom, which is what? 15 squared, and that's going to give me my answer. So I do that with my calculator, and what do I get? You should be practicing. 26.6 sounds about right. So where do I put that number in this formula? For the S. So let's write it out. Surface area equals pi, what's R?
Radius
15 squared, plus pi, what's R? 15. What's slant? 26.6. Now, here is one new thing. In grade 10, we like leaving pi as pi. We don't change it to any kind of number. Okay? So this, 15 squared, is 225 pi. We leave it as pi. Is everyone cool with that? And then this one is 399.4 pi. Because 15 times 26.6 is that. Or something close to that. Everybody cool? Now what do I do if I have 225 plus 399.4? Add it to get 624.9 pi. That's what I want to see for an answer.
24.9.
Oh, 0.4. Sorry, 0.4. Thank you, Jashin. 0.4. 0.4. I changed it. Everybody cool? Okay. Oh, good. We still have enough time to do the last one. Yeah, that was the slant. Okay. What shape's a Popcan? Cylinder. So what's on the top? Circle. What's on the bottom? Circle. What's in the middle? A rectangle. So I have the surface area of a cylinder is what?
20 centimeters.
No. What makes up a cylinder? Two what? Two circles. So how do I do area of a circle? 2 pi r squared. Right? Plus a rectangle, yes? That rectangle is normally length times width, right? Well, we got the width that's right there. Yeah? But how do I get the length? It's the circumference, isn't it? Right? Because if I take this rectangle and I roll it around a circle, the circumference is this distance, isn't it? What's the circumference? What does circumference equals? Who can remember?
Oh, pi.
No, that's area of a circle. Pi d. But wait a minute, Myers, and wait a minute, Jashin. We're dealing with r's. So what should I change that d to? How many r's are in a d? 2. So circumference equals 2 pi r's, because there's my d, 2 r's. With me?
Yeah.
So what then is my rectangle? 2 pi r covers around the outside. What would you call this? You would call it the height. Unless you laid it down, but you would still call it the height, wouldn't you?
Yeah.
Because if you lie down, Sam, you're still 5 foot 9 inches tall, or however tall you are. Right?
Yeah. Sure.
So let's fill it in. Surface area equals 2 pi, what's r? Excellent, I didn't fool anybody. Squared. Plus 2 pi, what's r? What's h? 20.
That's surface area.
That's surface area. What's 5 squared?
No, the surface area of a 20 centimeter cup.
Okay. What's 5 squared?
25.
Times 2?
50.
50 pi. What's 5 times 20? Times 2? Plus 200 pi. What is 50 pies and 200 pies? 250 pies. Yum. Now,
What type of pie?
bumbleberry.
Pie flavor.
Bumbleberry, I don't even know what bumbleberry pie is. There's no plant called bumbleberry.
Yeah, but it's a mixture of
Is it a mixture of what?
blueberries, blackberries, and I believe raspberries.
Oh, that sounds delicious, actually. I've been making fun of bumbleberry pie my whole life. It's that.
The jam is really good.
It's blue, black, and raz.
I believe.
That's sweet ass. That is a triple threat of berry awesomeness. That is what that is. Man, if that was in a triple threat match for the heavyweight belt, I don't know who would win. We're not quite done. What's the other way you can write this? One sec. 250 times pi, and that will give you a number. It's like 798 or something. Because this is the third time today I've done this class. 798 point blah, blah, blah. 789? 85. It's 785? Okay. Oh, there's the 398. 798 point blah. Which of these do I want to see on a test? Or do I care? I really don't care. Right? I really don't, because it's the concept that I care about. When you go further in math, you're going to stop doing this, because this isn't an exact number, because that blah, blah, blah goes on forever, doesn't it? Because pi goes on forever. It didn't. Not if you use the pi button. If you push 3.14, it will stop at 3. But if you use the pi button, it will go on forever. So this is exact. Now, Riley just asked me if there was going to be homework. There isn't, and here's why. This stuff, although look how easy the math is conceptually difficult. Yes? So tomorrow I'm going to give you work, but I want you working on it here where you can work with each other and discuss it. Okay? Because the building blocks of this part of the unit are really easy, right? They're Lego. Put it together, build something. But to do the math, you got to build the Death Star out of Lego, which is difficult, even though each piece is simple. Picking up what I'm putting down. Yes. I want you to go home. I do not want you to worry about math. You're going to come here tomorrow. You're going to spend the day working on this stuff with each other. Okay? Because when I mark your tests in a week, it always surprises me. Because everybody looks me right in the face and says, I got this, Myers. then I give you a test, and you don't got this, kid. Okay? So we're going to work on it tomorrow. I want you working on it here together with each other. Yes.
Where's that picture of Mr. Van Being?